So we learned about exponents and we started coming up with some exponent shortcuts last week. It's been a little while, so probably a good idea for us to review. So if I were going to write this out, there would be 7 x's here, 1, 2, 3, 4, 5, 6, 7, and another 4 x's here. And if we combine all those x's together, there would be 7 and 4 altogether. That's 11 x's, x to the 11th. Did you come up with x to the 11th for part A? Was anybody able to do it without writing out all the x's? So you guys starting to use those shortcuts or think through? That's good if you did. All right. Here for part B, I would have had 3 copies of x, but then I would have made 3 copies of that. So there's 1 copy of 3 x's, 2 copies of 3 x's, 3 copies of 3 x's. Altogether, we would have 9 x's, x to the 9th for the final answer there. Part C, if I wanted to write it out, I have 14 m's on the top. 9, 10, 11, 12, 13, 14, and 2 on the bottom. And if I cancel 2 on the bottom with 2 that were on top, we get rid of all the ones on the bottom. We'd still have 12 left over on top. So m to the 12th for the final answer. All right, part D. I got 2 x's in here, but I'm going to make 4 copies of them. How many x's am I going to have altogether if I make 4 copies of 2 x's? 8 x's. And same thing with the y's. I got 2 copies of y's, but I'm going to make 4 copies of that. So x to the 8, y to the 8. Does anybody have 4 out of 4 so far? All right. Now the last 2 are trickier. The last 2 are more like what we're doing today. So if you didn't get these answers 100% correct, that's okay. I would want you, by the time we finish today, I want you to be able to get these answers correct. So if you didn't get them right now, that's fine. Final answer in part E was going to be a fraction. I'll just tell you what the answer is. You'd end up with 3 x's left over on the bottom and 8 y's on the top. However, there's another way to write this answer, and Victor, maybe you did it this way. Did you write yours as x y to the 8 times x to the negative 3 by any chance? Did you use a negative exponent again? You did this version of it? Okay, that's cool. You did the bottom one? Okay, that's awesome. So you also already kind of have an understanding about negative exponents. So that's going to be our goal for today. In this one, our final answer here is going to have a, let's see, x to the 10th on the top. It would actually have a 4 on the bottom. Some of you may have left a 1 on the top with that x to the 10. Anybody leave it as 1x to the 10 over 4? The 1's really not necessary, but could be in there. And that'd be our final answer there. All right, does anybody have any burning questions on these 6 problems? Well, let me ask you this. Does anybody have any questions at all on A through D? Those are the ones we got to know by now. We're feeling pretty comfortable with those ones. And then we'll get into some of the more fractiony ones with what we're going to do today. So there are some shortcuts. And we're going to put our shortcuts into our packet. I think that would probably be a good idea. At least I'm going to. You can choose whether you want to or not. Let's see here. We got a learning log for 0 and negative exponents, which is probably what we're going to put in for today. You know what? I think I'm just going to combine it together because we don't need all this space for 0 and negative exponents. I'm just going to cross that out and say exponents. Let's just do all of our exponents in here. So I'm going to take some notes on shortcuts right now. because many of you are already starting to use the shortcuts when you're doing these problems. Now, when I say shortcuts, what I mean is going straight from the problem to the answer without writing out all of the X's or M's or whatever. And this is actually based off of, if you still got your book open, that's fine. If you don't, that's okay, you don't need it. And you're not going to need your book for a little while, so feel free to close it up and set it aside for right now. Get it out of your way. But this is kind of based off of number 13. So I'm going to write down what it says for generalization. This is going to say x to the m times x to the n equals what? So in this case, we're multiplying the bases. I'm going to make a note of that. We're multiplying two things with exponents. When we write our final answer, what are we going to do with those two exponents? Yeah, say it louder. We're going to add the two exponents. So this would be x to the m plus n. So when we multiply two things with exponents, the shortcut is to add the two exponents. And I think it's a good idea when I'm doing notes to give myself some examples. So I'm going to write an example off to the side here. And I'll just use the one that they put in the book, x to the 25 times x to the 40th equals. So we're multiplying on the outside, so we would add the two exponents. 25 plus 40 equals 65 would be our final answer. So we added the 25 and the 40 to get 65. So anytime we see an expression that's got stuff being multiplied together with exponents, we can just add the exponents together. We don't have to write them out anymore. Right. The next one, the next shortcut is when we're dividing, we have a fraction. X to the m over x to the n equals. Now, normally this week with this, we would have written out a bunch of x's on the top and a bunch of x's on the bottom. We would have canceled them out. But what did you find you were able to do to make this go faster for you? We subtracted the two. So this would be x to the m minus n. So what we're doing here is we're dividing two things with exponents. And when we divide two things with exponents, then we end up subtracting the exponents. That's the shortcut. And again, I'm a big fan of having an example. I like notes, and then I like a good, solid example I can look at. Remember, these are your notes, though, so if you want to do something different, that's fine. The example they gave in the book was x to the 36 over x to the 13. We're dividing those two things with exponents, so we would just subtract. We'd think to ourselves, what's 36 minus 13? 36 minus 13 is 23. So x to the 23 would be our final answer there. I wonder, it might help me to have a little thought bubble here that says 25 plus 40 equals 65. And 36 minus 13 equals 23. I don't know. I like to sometimes I just look at an example and I see the example and I'm like, okay, I see a couple numbers there. I don't know where I got that number from though. So it's nice to know what I was thinking when I did it. Again, your notes, your choice. All right, the last situation that we've seen come up quite a bit is when we have parentheses with an exponent on the inside and outside. So let's do x to the m to the nth power. So in this case, we're dealing with parentheses. What do we do with our exponents in this case? This would have been kind of like we did in part B in the warm-up that we were doing just a moment ago, right? What could I do with 3 and 3 to get 9? And multiply them. So in this case, I would multiply my two exponents, m and n. So it would be x to the m times n. So we are multiplying. And how about another example? They did x to the 5th to the 12th. So if I wanted to work this problem out, I could, oh man, if I wanted to, I could write out 5 x's and then make 12 copies of that. That'd be a whole lot of x's. Or I could use the shortcut and just go straight to x to the, what is 5 times 12? 60? X to the 60. I'm going to go ahead and do a little thought bubble here. 5 times 12 equals 60. That's where I got it from. Oh, that's really hard to see now. 5 times 12 multiply. It's good it this way. You're welcome. All right, so we got ourselves a little cheat sheet for exponents. But I'm going to tell you that sometimes, especially when you're dividing, some weird stuff happens. In this part, I'm not going to put this into my packet just yet because I want us to experiment with a little bit and make sure we understand it. And then once we really get it at the end of class today, we'll come back and we'll add some more stuff to our packet. So I think it's probably a good idea to have this out, to leave this out so that you can reference it. What I'm going to do is sort of tuck my packet back behind my notes paper like this so I can still see it up there, but it's kind of out of my way. And I'm going back in the book, but you don't need to open up your books right now. Not just yet. Just copy what I got on the screen. This is number 15. And we're just going to do 3 problems here. So part A, I'll go ahead and write them down and you can start working them out. Here's my book. 15 part A is x to the 4th over x to the 5th. Part B is x to the 2nd over x to the 4th. And part C is x to the 7th over x to the 10th. Now these all look like one of those rules that we just did. Looks like that second shortcut that we just talked about, doesn't it? It's got the fractions in it. So I'd like you to apply that shortcut and get the answers for these 3. All right, I'm only going to give you a couple of minutes on this because we only got 3 to deal with, and then we're going to talk them through. So 2 minutes. When you finish, compare with somebody who's sitting near you, or spy on somebody who's sitting near you, see if you agree with them. Come back in 2 minutes. All right, that should be long enough here. So, that was interesting. I didn't get all the way around the room, so I didn't get to see this half, but I was expecting to see a lot of the same mistake. Let me show you the wrong answer I was expecting to see. And I didn't actually, everybody seemed to be getting this right. Let me show you the wrong answer. Okay, so if you wrote this down, you would be incorrect, but it's a very common mistake. So maybe some of you over here have these answers. But anybody do x to the first and x to the second and x to the third for your final answer? Anybody have those? I told you they were wrong. So if you're wrong, that's all right. All right. We're just learning this stuff. For somebody who would make that mistake, can somebody give me like a hint to fix it? What do I just need to do? I'm pretty close on these answers, just not 100% correct. I'm only missing one thing. What do I need? I need negative exponents. Yeah, these should all be negative exponents. You guys all had them as negatives? Cool. So it's really easy to get the wrong answer on these because it's really easy to look at this and say, ooh, 4 and 5, you know we're going to subtract, right? If you came up with 1, then you knew the shortcut was to subtract. It's just you subtracted the wrong way. If I do this, it's always the top exponent minus the bottom exponent. So when we do that subtraction, we got to do the top exponent minus the bottom. So 4 minus 5 is -1, and that's why it's a -1 instead of a +1. If you had a +1, you were thinking 5 minus 4. You were just going backwards when you did your subtraction. Same thing here. Always the top minus the bottom. 2 minus 4 is -2. That's why it's a -2. 7 minus 10 is a -3. That's why it's negative. So if you didn't have those negative exponents to begin with, that's okay. That's okay. That's a super common mistake. You've made it now once. Remember, you learned from your mistake and you don't have to make it again, right? I think it's probably a good idea if we did make that mistake, and maybe even if you didn't, to go back to our notes here and make ourselves a little note. How am I going to do this? I'm going to make a little star right here. And I'm going to make myself a little note off to the side that says always top minus bottom. In hopes that I will not avoid making that mistake if I ever come across that in the future. We always do the top number minus the bottom number, not the other way around. Even if it makes us come up with negative exponents, that's okay. All right, so we got that note down. So I want to tell you that there's another way we could write each one of these. I'm going to show you how to rewrite the first one. I'm going to ask you to rewrite the second one for me as well. So x to the -1 is a correct answer, but like a lot of things in math, sometimes there's more than one correct answer. Sometimes there's 2 different ways you can write the same thing. Here's another way that we can write x to the -1. 1 over x to the first. That's the same thing, and that's also a correct answer. Could you translate the other 2 problems answers into that alternate format for me also, please? I'll give you a hint. It's going to be 1 over for both of them. Can you finish those other 2 up for me and write them down on your paper as well? What's another way I can write x to the -2? What's another way I can write x to the -3? Did you write 1 over x squared and 1 over x to the third? All right. All right, I want to show you something really important. This isn't in our book. Okay. So really important that you pay attention here. Our goal, one of our big goals today is to deal with negative exponents. And negative exponents happen sometimes when you're dividing. You've got a bigger number on the bottom. There's another way that you can deal with negative exponents aside from writing it with a negative exponent and writing it as 1 over something. So I want us just to do one example that's not in the book. So just call it example. And I'm going to go, let's see here. I'm going to go A times B to the negative 2. And on the bottom, I'm going to put C to the 3rd times D to the negative 4. And I'm going to write down what my final answer is. And I want you to see if you can figure out sort of a shortcut that we could use to get to that final answer. So final answer for this is actually going to be A times D to the 4th. Sorry, I wrote that backwards. Not B, but D over C to the 3rd times B squared. Yeah, it's weird, isn't it? Write it down, look it over, see if you can figure out what's going on here. It's weird. It's a weird one, I admit. Anybody think they got this figured out? How do we go from this to this? Check out the B. All right, so the B started in the top and it ended up in the bottom. Here's my first question to you. Why did the B move to the bottom but the A did not? Because it didn't have a, this is called an exponent. Now the A does have an exponent. What is the exponent on this A? It has an exponent of 1. So it does have an exponent, but you're on the right track. The A does have an exponent, but what else? It doesn't have a negative exponent. The A has a positive exponent, so it stayed where it was. The B had a negative exponent, so it moved down to the bottom. All right, look at the bottom of the original fraction. The original fraction had C's and D's on the bottom. Now the D's moved. Why did the D's move? But the C's did not. Because of the negative exponent. This D also had a negative exponent, so it moved upstairs. But the C stayed where it was because it had a positive exponent. You get the idea? So things with negative exponents can move to the other side of the fraction mark. I want you guys to try another example of this with me here, okay? I want everybody to write this down. W to the negative 2, x to the 3rd, over z to the 4th, y to the negative 6th. And you use that same idea that we just did a moment ago to rewrite this so it does not have any more negative exponents. Still gonna have a fraction. Some stuff's gonna stay where it is, but some stuff's gonna move to the other side. There, you got it? Are you writing this down? We're just in our notes right now, not on the packet. But you can put it in the packet if you want. It's up to you. All right, there's two things in this problem that are going to move. What are the two variables that are going to move? The W and the Y are going to move because they have negative exponents. So those are going to move to the other side of the fraction. The X and the Z's are going to stay. So if I were doing this, usually I take the stuff that's going to stay and I just copy it down first. It really doesn't matter what order you have these in, as long as you got that X to the third on the top still and that Z to the fourth on the bottom still. The W is going to move downstairs and it's going to become a W to the second power. Instead of -2, it's now +2. The Y is going to move upstairs. It's going to become Y to the sixth power. It's +6 instead of negative. So things with a negative exponent move to the other side of the fraction. Now you've got to be careful. If this had originally had a 3 and a 5 on the top and bottom of the fraction, go ahead and write that, squeeze that 3 and that 5 into your original. Are either of those going to move? Are the 3 or the 5 going to move? One of them is, but one of them's not? Or both of them going to stay put? The rule is things with negative exponents move. Do the 3 or the 5, do either of those have a negative exponent on them? They both have their own exponent. I didn't write the exponent on either one of them. What is the exponent that's on both the 3 and the 5? They both have an exponent of 1. So are either of those going anyplace? No, they would stay right where they are. The 3 and the 5 would just stay because they both have positive exponents. All right, one more. Just to show you we're not totally crazy here. X to the -3rd. If we use the same idea that we were just using, we should be able to come up with the same answer that we did over here. This is why it ends up being 1 over x to the third. Because what happens to things with a negative exponent? They move to the other side of the fraction. Now, there's no fraction written there, but we know that we can write anything as a fraction, right? So x to the -3rd, that x to the third is going to move downstairs because it's got a negative exponent. So now we're going to have x to the third down there. Now we can't leave the top of the fraction blank. We have to put something in there. If everything goes away, then we got to put that 1 in. Good. So that's why x to the -3rd is 1 over x to the third. All right. Your turn. Your next task is number 16. So if you can open your books back up, this is on page 99 now. I like you working on number 16. And I'm going to give you about 5 or 6 minutes to do this. We'll go over answers. And then we're going to put some stuff into our packet, and then we'll be done for the period. All right? So get out there. Number 16, you got 8 problems to do there. Yeah, absolutely. Feel free to work with somebody who's sitting near you. Okay, some of you may still be working. That's okay, but eyes up here. Pause what you're doing right now. I'm going to show you a problem that we did not do. It's not on this. It's going to help us with part B, though. So eyes up here really quickly. If I gave you x to the 14th over x to the 14th, and I asked you to do the shortcut on it, what does our shortcut tell us to do with these two exponents? I'm sorry, I'm frozen still. I'm off of freeze now. If I give you x to, you don't need to write this down, just watch, okay? If I give you x to the 14th over x to the 14th, what would our shortcuts from our pink packet tell us to do in this situation? Add, subtract, or multiply? We would subtract. And what is 14 minus 14? 0. Now, if we did this another way, if we thought this through, and you've known this for a long time now, what happens when you take a number and you divide it by the exact same number? What do you always get? 1. The answer is 1. If I asked you to do m to the 20th over m to the 20th, that would be 1, wouldn't it? But it would also be m to the 0. Agreed? So there's a rule with exponents. When I take anything and raise it to the 0th power, what's it equal to? 1. So if I asked you to take 45 to the 0th power, that's 1. If I asked you to take d to the 0th power, that's 1. Okay? I always have a question on the test, usually it's on the final exam, that says something like 2x to the 5th, y to the 72nd over x to the -7th, y to the 3rd to the 0th power. And that's an easy problem because the answer is what? The answer is 1. Anything, no matter what, no matter how complicated that thing is, if you take it to the 0th power, the answer is 1. Okay. So we'll make sure we get that in our pack in just a minute, but let's keep that in mind for part B. In fact, let's just do part B right now. What is m to the 0? Final answer is 1. All right, k to the -5th. Did you write 1 over k to the 5th? Did you move it downstairs and call it a positive exponent? Yes. Hooray, you got this. All right. Part C has got a positive exponent and it's got a negative exponent. If we put it all over 1, we can move one of those things downstairs. Which one would move? One with the negative exponent is going to move, correct? So that guy is going to move downstairs. We're going to end up, the x to the 5th is going to stay up top. The x to the 2nd is going to go down to the bottom. And that's great, but we got one more step to do. What's our shortcut tell us to do with this 5 and this 2? Add, subtract, multiply, subtract. Top minus bottom, right? 5 minus 2 is 3. Final answer is x to the 3rd. Pausing on part C, there's another way to do this problem. When you see x to the -2 and x to the 5, doesn't this kind of look like our first shortcut? Look at your pink packet and look at your first shortcut. This looks a lot like my first shortcut here, doesn't it? And what would you do with those two exponents when you're multiplying two things together? We said we add them. So what are you going to get if you add -2 plus 5? You're going to get x to the 3rd. You could go straight to the final answer without making any fractions in that one. All right, part D is a lot like part A. We're just going the other way. What is another way that I can write 1 over p squared? I can write it as p to the -2. All right, part E. Do you see anything that can move here? I do. I see a y that gets to move down because it has a negative exponent. I see another y that gets to move up because it also has a negative exponent. So we're going to end up on the bottom with the y squared, on the top with the y to the 3rd. And then we got to go one more step here because we do, they're both y's. What does our shortcut tell us to do with that 3 and that 2? Add, subtract, multiply. Shortcut says to subtract when we're dividing. 3 minus 2 is 1. Y to the 1st for our final answer. Bless you. Part F was a little tricky to me because I wanted to start moving this, but I actually think it's probably better to use my shortcut first. What does our shortcut tell us to do when we have exponents on the inside and outside of a parenthesis? Multiply them together. And what is -2 times 3? That becomes x to the -6. And then I would probably take that -6, move it down to the bottom. It would become 1 over x to the 6 would be my final answer for that. Part G is kind of like that. I'll probably do the same kind of idea. I do the shortcut first and multiply. I saw a couple people do this as I was walking around and made me really happy. This is a huge hint. If you're ever doing one of these problems and you see a letter or a number without an exponent on it, put the exponent on it. What invisible exponent is on this B? It has an exponent of 1 in it. Are any of you already in the habit of putting those exponents in, writing those exponents of 1 in? It's a really smart thing to do. It'll keep you from making some really common mistakes. So that b's got a 1 on it. Now, what does the rule tell us to do with the exponents inside and out? We're going to multiply them. So 2 times -1 for the a. 2 times -1 is -2. And for the b, we got 1 times -1. That's, well, -1. And it looks like this time both of those get to move downstairs. And there's nothing left on the top of the fraction. When there's nothing left on the top, we got to put something in there. What do we put in there? Yeah, the last one here. We got 1 over x to the -1. That x to the -1 gets to move because it has a negative exponent. It's going to move up to the top. It's going to become x to the +1 up top. There's nothing left on the bottom. We could write a 1 on the bottom. We don't really need it. X to the 1 is just x. So this really, the final answer would just be x. If you wrote it as x to the 1 over 1, that's technically correct. X is a little simpler though. All right, we're probably going to want to write some more notes in our packet about exponents. So let's go back to our exponents here. And let's do the 0 one first. What is x to the 0 equal to? X to the 0 equals 1. And for my example, I'm going to write this. Anything to the 0 equals 1. Is that confusing to you? Do you think that's going to be confusing for you when you come back and look at it? Anything to the 0 equals 1? If so, you might want to put some more examples like 5 to the 0 equals 1 and 42 to the 0 equals 1. Basically, anything we raise to the 0th power is equal to 1. There's one exception to this. 0 to the 0th power is undefined. But we don't need to worry about that in this class. I'll come up in algebra 2. X to the 0 is 1. And then the other thing we got to deal with is negative exponents. Let's do x to the negative m. X to the negative m equals, and we said that that moved down to the bottom. We ended up with a 1 on the top. That would be 1 over x to the m. And my example here would be something like, oh, what did we have in our notes? We had k to the -5. And that we just did that problem a moment ago, and we said that was equal to 1 over k to the 5th. And I'm wondering if it might be good to put like one of these examples that we talked about. Remember these ones? I wonder if it might be good to squeeze one of these off onto the side. I think I'm going to go with this one, this last one that we did. This is another example of negative exponents. We had 3w -2 x to the 3rd over 5c to the 4th y to the -6. You know, and just for fun, I think I'm going to make this 3 negative on the top. When we originally did this example, the 3 was not negative, but it is now. Does that change anything? Is it going to move now that it's negative? Is the exponent negative? The exponent's still a +1, isn't it? Which means it's staying. Anything that has a positive exponent stays. Anything with a negative exponent moves. So, in our final answer, the -3 staying, the 5 is going to stay. The x to the 3rd is going to stay, and the z to the 4th are going to stay because all of those things had positive exponents. The two things that are going to move are the w to the -2 and the y to the -6. The y is going to end up top with the positive exponent, The W is going to end up in the bottom with a positive exponent. And that gets us our final. So there's kind of a more complex example of negative exponents moving around. All right, you guys did great today. Thank you for your attention.